to the introduction to graded assignment number 3. This one is called Mars Rover. I'm going to talk first about the key concepts for this assignment, which areas of knowledge it's really focused on from all the chapters you've been learning recently. And then I'm going to give you the big picture. What is this assignment all about? Then we'll start looking at the instructions and the starter code and follow up with some common issues and tips that I would have to make sure you can get through each section smoothly. And then some last reminders, and I will point you to some extra resources on my website. Some of the core concepts are covered by this assignment are importing and exporting modules, unit testing with Jest, the process of test-driven development, and handling exceptions, and also classes. There will be 3 classes. You do not, however, have to worry about class inheritance, but that's the focus, everything from chapters 13 to 18. However, you also will, of course, build this on a foundation of your knowledge from previous chapters. Definitely, there will be conditional logic you'll need to have, and you'll have some arrays and array methods that you're working with. You'll need to iterate with loops in some situations, and then JavaScript objects are going to be all over the place. And you're going to need to remember how to create key value pairs, how to access the values of keys, and then you'll definitely need a strong understanding of more complex data structures than you really have been working with up until this point. So objects within objects, arrays within objects, and then arrays of objects, because you're going to be building an object that has a lot of nested data inside of it as part of this assignment. So you're going to get a lot of practice with this. Now let's look at the big picture. You are going to operate a Mars rover. So you're going to send one or more commands in a message from Earth to Mars. And there are 3 different possible message types that you might send. Move, and you'll tell it some position to move to. Mode change, to either go into normal mode or low power mode. And then status check, which is just you're asking it to give you a report on how it's doing. And so you're going to send this message, and you'll have some sort of a string that just says what the message is, but then you'll have this list of commands. And again, you can have 1 command, you could have 6 commands, you can have a whole list of commands, and you'll send it to it, and then it's going to receive the message and process each one of those commands one after the other. Once it does that, the rover should return a response, and there should be a result for each command that was sent. So the response will come back, and it'll have a copy of the original string from the message, but it'll also have these objects, and each one of them corresponds directly to a command. So you can imagine if you were to send 1 command, that means when you get this response back, it's going to have 1 object in its results. If you had 4 commands, you would have 4 objects in the results as part of the response object. And we'll look at the details of how all of that data will be structured in a minute, but this is the concept, right? You're just going to send messages with commands and receive a response back. So let's take a look at the instructions and the starter code. If we head on over here to the assignment instructions in the book, we have this first page that doesn't really have much on it other than to give us the links to the 5 different tasks. So we can jump straight into task 1 here. And it gives us a little bit of an overview, as I was just explaining, about what it is that you're trying to go for. But they do talk here about how you're going to create 3 different classes: command, message, and rover. And each of those is going to have its own properties. And rover is going to have not only some properties, but also a method, a function of that class. And you will be practicing the process of TDD as you write these, so that you write the test before you write the code that passes those tests. So you can read through this and get a better idea, but I'm going to keep going, and we're going to look at each of these in turn with the individual tasks, because command, message, and rover are what we build in tasks 2, 3, and 4 respectively. So in addition to the overview requirements, there's also a link to the starter code repo here, right here. And just as a reminder, whenever you go to get code from LaunchCode, you want to fork it to your own account first. Then you want to enable GitHub Actions, and then you want to clone it down to your local machine. Once you've done that, run npm install to make sure the dependencies are installed into the application. The next thing that they have is just a reminder of how the TDD process works. So they kind of run through this reminder. You focus on one test at a time. You write the test first, it'll fail. Then you write the code that's going to make it pass. And you only write the code that's needed to make just that one test pass. But then, of course, as you add additional tests, you want to make sure that the original tests are still passing as well. There are going to be 13 tests, and you're going to need to write them just a little bit at a time. They will be broken down by the 3 different classes, and I will go over that in just a minute. So that sounds like a lot, and it is, but you'll just do them one at a time. So don't be overwhelmed by that, because every time you build a new part of this application, it's going to just unfold just a little bit at a time, and it won't seem so overwhelming. They do warn you here, do not try to write all of the tests at once, because it will be inefficient and will cause excessive frustration. So they're very clear that it's a bad idea to try to just tackle it all at once. And I can definitely attest to that. You want to do it just a little bit at a time. So yeah, there's a reference here to it statements that I wanted to point out. It says right here, use the given phrases as the descriptions when creating your it statements. So we used to teach Jasmine before we started doing Jest, and it was always called an it statement, but that's the same thing as saying test block. And you can actually use those interchangeably. They'll both work, because Jest was built on Jasmine. So you could use it, but we are teaching you now to say test instead. And when we get to the starter code, you're going to see an example of that. Okay, so let's see. I think we can move on to talk about the file structure. Yes. So there's going to be a package.json file that has all the dependencies that are needed. Make sure you just run it npm install to get those installed. Don't modify anything except the following 5 files: command.spec.js, which is here in the spec folder, message.js and message.spec.js, rover.js and rover.spec.js. Those are the 3 classes and the spec files that correspond to them, the test files. And we have been teaching you recently with Jest to call your folder test and to name them command.test.js. Spec is the way that it used to be done with Jasmine, and they kept it that way when they updated this assignment. So don't worry about that. It does exactly the same thing as if it were named test instead of spec. No problem. You'll notice that command.js is not here. The only reason that that's not listed here is because it's already written for you, and we're going to look at it in just a minute. You're going to temporarily comment a couple things out so you can kind of see how the tests work, but you don't really need to alter any of the code because it's already finished. So the only thing you're going to have to finish for the command part is the test file itself. You don't need to run your program. You're not actually going to be having any sort of executable code itself. The focus for this is just on the unit testing. So you'll be using npm test a whole lot in order to run those 3 files, and there will ultimately be an autograder file that you're going to run as well. You'll just do that at the very end. After you have all of your own tests passing, the first 13 tests, you'll be instructed to change the extension on the autograder test from specx to spec. And that way, Jest will pay attention to it once you do that, and then it'll run that 14th test. but don't worry about that for now. So let's take a look at it. Come over here and look at this code. So you've got your spec folder here. That's the test folder. It has some things you don't need to worry about, some helpers and support folder. Don't worry about that. These four are the test files, command, message, and Rover. Each are the place for you to write the unit tests that correspond to those three classes, which are down here, command, and then message and Rover. And this is the test that has the, this is your auto grader test that currently will not run because it says spec X instead of spec. So you can leave that alone for now. All right, and you'll notice I've already run npm install, and so I have my package lock file. I've got my node modules. So that part has been done. But all I have for right now is the command class that's already been written, and then the command spec file where it does have one test here. So let's take a look at that. This is task 2, the command class. So again, that code has already been written. It doesn't need to be changed. And the first test has been written. There are 3 tests. So you're just going to have to write test 2 and 3. So they start off talking about what the command class is meant to do. And it really just has 2 properties. You're going to pass in these as parameters and then store them as properties. The command type, which is just a string that would be the type of command. And it's going to be one of the 3 that I mentioned before, mode change, move, or status check. And then you'll have a value, and this value could be a string, it could be a number, it depends on what the command is, the command type is. But those are the only 2 things you need, and that will make up the entire command. So they give you an example here of how you might create an object of the command class and pass in a string for the command type, and then the value that goes along with that command type. In the case of mode change and move, you have values. In the case of status check, there is no value. You can actually just leave that off. And you can learn more about exactly what these mean when we get to the Rover modes table. And the command types table, we're going to jump to that in a bit. So the tests themselves, you're going to have 3 tests. The first one has already been written. And all it does is test, it says throws error if a command type is not passed into the constructor as the first parameter. Now, they mentioned this on the very first page, but this string here, every time you see instructions for a test, it's going to give you a string, and you should just copy and paste this in. I would say avoid copying those quotes though, because those are not code style quotes. You need to just copy the text that's between the quotes. But use that text for your specific test description when you pass it into the test block. And you can do that for every single one. It'll give it to you. So for this first one, they really just want you to kind of verify it. So we can take a look at that. Then we'll get to looking at these next ones. I also wanted to point out that it's a very good idea for you to label your tests with some comments, because you're writing 13 tests. And I promise you, especially when you get to the Rover class and you have the last 7 of them all in one place, they're gonna run together, and you're gonna have a hard time, like you're gonna be scrolling up and down and be like, wait, which one was I looking at? So get in the habit of just putting a little comment over each one to label them. And yes, use that exact string that's given in the instructions. Okay, so if we come over and look here at this test for the command class, we can see that it says it throws error if command type is not passed into the constructor as the first parameter. That's exactly the string that came from the book. And then it has this thing where it says, I expect that if I try to instantiate an object of the command class without passing in a command type, that it's going to throw an error with a message called command type require. Now, this is not a matcher that we taught you as part of the chapter and in the lecture, but that's why they provide this for you here, is so that you can see how to do it. But it does run a little bit differently than some of the tests that you've set up before. But we can go ahead and run it and just see how it works, and we should see that this code does satisfy it. So I'm going to open my terminal and just do an npm test. And I want to show you something interesting that's about to happen. We're about to see some failures. And here's why. It sees that rover.spec.js exists, and same thing with message.spec.js, but there's no test. It says your test suite must contain at least one test. So it's normal that you're going to have two failing and only one passing, just because we haven't gotten there yet. So one of the ways that you could get around that so that you don't have to worry about that right now, since you're not really supposed to start on those tests until you're completely done with the ones for command, would be to use the extension Jest Runner that I have installed here, and just run the test individually, or or just by file. So if I go back to command.spec.js, I have these little hot links here for running either an individual test here, or the entire describe block here. So I could run just this, and now it skipped over running anything that was over in message and rover test files, and just ran this, and it passed, no problem. Okay. This is also a good time for me to point out, you see how this says it? Yeah, that's the throwback to Jasmine. It will run because, again, Jest is built on Jasmine, but you can change this to test like you've been taught now with Jest, and write all of the subsequent tests with it. And here's a good example of where I can just go ahead and start labeling these things, right? And I could say there's test 1, and down here I'm going to put test 2, and down here I'm going to put test 3, and just continue to do that in the files. So this one will have test 4, 5, and 6, and this one's going to have tests 7 through 13. Okay. So they tell you over here in the instructions that you should run the test and watch that it passes, and then comment out the lines that are making it pass so that you can understand what's happening here. Let's just do that. I'm going to do that for you, and we'll see how it works. So I'll take lines 4 through 6, comment them out, and then run the test again. And it says it fails, right? Expected the message command type required, but it received function did not throw, because we took this out and it didn't throw it when we had no command type. So we can put it back and run it again, and of course it will pass now again. The other thing that they want you to do is to change command type required on line 9 in the test to oops. So we're actually going to test for something different than what is in the code here. So we'll change this to say oops, and then run it again. All right, now we see it failed in a failing in a different way. It says it expected the message oops, and it received message command type required. And of course, we actually want command type required, so we need to fix our test. So this is an instance where the test was actually wrong. So pay attention to what you're testing, and make sure that your test is actually testing what it's supposed to test for. And then, of course, that the code actually makes it pass. So I'm going to undo that to put it back, and then everything should pass again. I wanted to spend one more moment here just talking about this test, because again, to throw is different. You're not accustomed to having to seeing an anonymous function having to be written to test code. So I'm going to break this down just a little bit. Let's take this out and actually remove it here and store it in a variable instead. So I'm going to call this instantiate command, and then store this function definition in that variable. And now we can say we expect instantiate command to throw the error, and then it's going to, it should be looking for this particular message. So what's happening here is that we're not testing a function definition, but it has to be done this way in order for it to attempt to instantiate something, because instantiation means the object doesn't exist yet, right? Every test you write after this, these other two tests, you're going to create a real object and then test the properties of that object. In this case, you're trying to create an object, but you can't, and you're throwing an error instead because the constructor runs and it says, oh, I can't even create this object. So that's why it has to be done this way. Hopefully that helps you understand a little bit better why this is so different than the way that some of your other tests have been set up. When you move on to test 2, you're going to be writing tests the way you're accustomed to writing them, where you just create the object and then go test its property. So again, this class definition has 2 parameters and 2 properties, command type and value. And you can just take both of those in, take in the arguments, and then apply them directly to those properties so that they're stored with the command. And there are no methods for this particular class. Now, the last 2 tests that need to be written here are to test the command type and the value. You just want to write one test to check that the command type has been set properly, and then another one to check that the value has been set properly. And that's it. Once all 3 of those are passing, you can move on to the message class. So this one's going to work fairly similarly to the way that command did. You're going to write all 3 of the tests though, and you definitely want to make sure you're practicing test-driven development here, where you're writing the test before you write the code that satisfies it. And you'll have 3 more tests, tests 4 through 6, label them, and then keep using the strings that are provided for you by the instructions. So if we look in the instructions here, they talk about how this is going to have a name and command, a name property and commands property. Name is a string that's just the name of the message, and commands is an array of command objects. So you'll actually create commands and then pass them into the message in an array. And it looks like this. You could have an array of commands and then create a new object of the message class and pass those commands in along with your name string. So the tests that you'll write for this are to test that it throws an error if a name's not passed in. So this will look very similar to the way it was in command. And then 5, make sure you set the name properly, and 6 is make sure the commands array gets passed in correctly. And so very, very similar to the way that you're going to have done the first 3 tests is how you'll do these. So again, the params and properties here are name, and then commands, which is an array of command objects. Both of those are going to be required. There are no methods for this one. And we'll just look at the code real fast to make sure that you see that there is pretty much nothing here in the message class. It exists and it's exported, but there's absolutely nothing here. So you're going to have to set up the constructor and make sure that those properties are getting set and that an error is thrown if you try to create a message without passing in a name. And then here is where you're going to want to put, test 4 and test 5 and so on and so forth. Notice here at the top that both message and command have been imported. So that tells you, you're going to need to create command objects in order to create a message object, just like it showed you in the example up here. So this is a great example of how you're going to set up data in order to be able to run your test, because you have to have these objects exist in order to then test it. Okay, task 4, once you have the first 6 tests passing, you move on to task 4, you've got the Rover class. This is the big one. But if you take it a little bit at a time, it'll be all right. So again, you're going to add code in rover.js after you write each test, and you're just going to build it a little bit at a time. It'll be tests 7 through 13. Definitely label them so that you can keep straight where you are as you're scrolling around. And make sure you keep using the strings that are provided with the tests. Like, I need to switch. Yep, here we go. Like here, they have the strings here for you. Okay, so yes, 7 through 13 is what's going on here. And the class definition, it has a position, which is a number, a mode, which you should default to string normal, and generator watts, which should default to the number 110. And then there's a method. This is the only class that has a method, but it's the big one. It's the one that processes the commands and returns a response. So it's called receive message, and you will pass in a message, which is just an object of the message class. And then after processing through all of the commands that were included in that array as part of the message, it should return an object that repeats that string back that was part of the message, and then also has an array of objects in a results key. And we're going to need to look at the instructions to understand how these objects are going to be formed, because it's going to depend on what the commands were. But you remember I had my little diagram at the very beginning of us sending the message from Earth, from NASA to the rover, and then this response coming back. The response is what contains the message and the results, and the results are where we have an object, one for each command that was given. So let's look back at the instructions here and kind of start at the top. So again, position, and you'll set this dot position to that position. And you'll notice that they're telling you the constructor really only needs to have the one parameter, because you can just set mode and generator watts to default to normal, and you can just do that in the constructor without needing to actually pass them in, because they're the types of things that you won't ever change until you do it with commands. You'll change mode with a mode change command, but it should always begin at normal. Receive message is the one where, again, you pass in a message object. And so the parameter message has nothing to do with this message right here that's a key of an object. You're going to create a whole brand new object. It's not going to be an instance of any of the classes. It's going to be your response object, and you're going to have to build it from scratch. And it's going to have message and results. All you have to do for message is just use the same string that was provided with the message object that was passed in, and just save that as the value of this key message. And then for the results key, that's where you have an array, and you're going to add objects to it. Each object should correspond to one of the commands that was in message.commands from the message object that was passed in. So they give a really great example here, and I am really happy that they do it this way now, because when I was a student and this assignment was brand new, they did not do this for us, and it was real tricky to envision what it was that they wanted this output to be from the receive message method. So they have this for you now so you can see exactly what it should look like. So let's say that you're testing this and you create some commands and you pass those commands into a message object and create a new message. And then you create a rover with a position, and then call the receive message method on that rover and pass along the message you created right here, this object. You should receive a response back. Once you receive the response back from receive message, you can console log it and take a look at it. And we can see here that in response to these two specific commands, mode change and status check, we got two objects back in the results array. We also have the message that's just the exact same message that was passed into the message object here. So that's basically just repeated back to us. We're just saying that this was the message that I'm responding to, and here are the results. For the first command, you gave me mode change and told me to put it in low power. I'm just going to return and say, no problem, I did it, completed true. That's what that means. The second one says, let's do a status check. And so it comes back and says, okay, I've completed the status check, so that's true. And I've got some information for you. And this is the report that the rover is sending back. It's saying, here's my status. And then the value of rover status is another object that has three properties: mode, generator watts, and position. And they correspond directly to the three properties that are saved in the rover itself. So all you have to do is provide whatever those current values are. And keep in mind that if we did a mode change and we told it to change from normal to low power, then we would expect that when we check on the mode of the rover now with the second command, that it's no longer normal and now it's low power. So that's why these values, should always represent whatever the current value is. And let's look at this in a little bit more detail so that you understand the difference between these commands. We're going to have to unpack this a little bit at a time, and it's okay. We'll come back up and look at this in just a second. And I'm going to skip over the test requirements for a second because I want to come straight down here and talk a little more about these command types. So again, three different types: move, status check, and mode change. When you send a move command, you want to send a number with a position the rover should move to. And then you should update the rover object because it has a position property, right? So you want to update the value of that property with whatever that number is, and then return it as true. However, down here, you learn that you can't actually move the rover if it's in low power, only if it's in normal state. So if it's in low power mode, you'll have to check that first. Then you would return completed false instead. They say that right here in this box too. You have to make it false if the command can't be completed for some reason, and that would definitely be a reason it can't be completed, is if it's in low power instead of normal mode. Status check, you don't need to send any value along with this. You can just send the type status check with the command. And then it doesn't need to update anything about the rover. It just needs to report back. So that's why this one has a lot more information, right? It says completed and gives true, but then it also has a second property next to completed, rover status, and it has this whole other object that gives us the values of the three things that are stored with the rover. So again, the values for those three things are going to depend on the current state of the rover. You'll have to go get them from the properties of the rover and then place them as the values for these keys in this object, which you're just creating for the response. Mode change is where you just send it whatever the mode is. It's going to be either low power or normal. And then you should update the property, the mode property of the rover with that value. And then just return completed true. And that's pretty much always going to be true because there's no reason you can't change it from one to the other. Okay, so now that you understand a little bit more of what all of these mean, let's just come back up and look at this one more time. Again, you'll create commands of the command class, objects of the command class. Then you'll take those commands, which are set into an array, pass that along with the string into a new message and create that object. And then that becomes the argument that's passed into the receive message method that you call on a new rover you've created. So you need to create objects of all three classes in order to test receive message. However, the very first test you write is not going to deal with that method just yet. The very first one is just going to test that the constructor has set the position and those default values for mode and generator watts. So this is going to look a little bit more like test 2 or 3 or 5 or 6 that you did for the command and message classes, where you're just checking to see if those values have been set properly when you create an object for the first time. Then test 8 is where you actually start working on receive message and filling out that method a little bit. And so you're just going to need to go through these one at a time. They test different things. The first one just says, hey, were you able to set the name of the message? So it's just checking for this property right here. And if you're practicing TDD, that means you're not worried about results yet. You shouldn't have anything in there about results because this test is only going to be concerned to make sure you get an object back that has a message key and it has the same value as the message you passed in when you called the receive message method on the rover that you create. Then you move on and you test the next one. Do you have two results if commands are sent, if two commands are sent? And it doesn't even really matter what the commands are or what the results are. You just have to make sure that it's a two to two relationship, right? So that would be test 9. And then you could start getting really specific with some of these status check, excuse me, with some of the commands. So for status check, make sure that the results will have that rover status object that has the state of the object with all 3 of those properties and those values. If you do a mode change for test 11, that it should come back with completed property, and then you should also check the mode and make sure it has been changed, which means you probably are going to have to send at least 2 commands to do that. And then test 12, if you try to move in low power mode, does it respond with false? And then if you try to move it when it's normal, does it actually move it to the new position? And then you'll have to check the new position. So one at a time, just take them one at a time. And again, that's going to be, you're going to write your code in the Rover class after each test that you write here in rover.spec.js. Okay, task 5 is just to run the autograder test file and submit. So this is where you're going to need to change the autograder file extension from specx.js to spec.js. I'm going to actually model this for you. And let me close all of these. So close all. Okay, I'm going to switch over to my solution, but I need to stash these changes because I can't take them with me. Okay, so let's switch to solution. Let me spell it correctly. Okay, now I'm going to run npm test, and we're going to watch all 13 of my tests pass. So good for me. Now I need to come over here and actually change spec X here to say just spec. And now I can run npm test again, and it's going to run 14 tests. And if all 14 of them have passed, you're in good shape. If you look at this test, you can see that they run through, they create a single rover. They started out at a position of 100. Then they run it through a series of commands: move, status check, mode change, change it to low power, try to move it again, then do a status check to see, what the values are. And then it goes through and it checks, what do we see in the responses, each of the results that come back in response to each of those commands. And so it's looking at the different properties to see what their values are. And you can see that, because it was this object here that has all of these nested data structures, arrays and objects that have nested objects, you have to use quite a lot of interesting, notation here, dot notation and bracket notation, to get to the values you're looking for. So your tests are going to look very similar if you're doing them correctly, where you're, creating your commands, creating your rover, creating a message and passing in the commands, and then calling receive message, and then seeing what those results are and comparing them against the values you expect them to be. This is just doing it all at once. And so here's my general advice about this is that if you get to this point and all of your tests were passing, but then you go to run this one and now it's failing, it probably means that one or more of your tests are false positives, and you're going to have to go back and make some changes. I'll talk again about that in a minute. But if it is passing, once you do have all 14 passing, you need to commit this and keep it this way, and then do one final push so that the autograder can run with GitHub Actions. Okay. Yeah, one last commit and push, and then you'll be good. Okay. And then you'll just submit your repo link on Canvas and let your IA know that you're ready for a demo. So some of the common issues that people run into and some tips that I have for dealing with them would be make sure you read the instructions thoroughly. This one is complex. There's a lot of good information in the instructions. They tell you at every step exactly what you need to do. So you just need to read it really carefully. And make sure you familiarize yourself with the starter code, that you learn your way around and understand what all the files are and what they're doing and where you need to put your code, which I've pretty much covered. Make frequent git commits, just a little bit at a time. Don't do a ton of coding and wait. At minimum, make sure you're doing a new commit after each test that you pass, so that you'll have at least 13 commits. Use temporary console log statements. Okay, I cannot understate this. So just because you're only running tests for this assignment doesn't mean you can't log things. So let's say I created a demo file just for this. Okay. I created a little file here called demo. I imported all of my classes so that I could demonstrate for you how to do this. You can also do it from your tests. I just can't show you that right now because then I would be showing you the solution because I'm in my solution branch. So here's what I'm going to do. I'm just going to click this little button here and copy how they've set this up right into this file, just like this. Boom. I'm going to have these commands. I'm going to have a new message be created that passes those commands in. I create a new rover, and then I call the receive message method on the rover, pass in the message object that was created here, and then receive the response and store it in a variable. And now I can log it. So if I go here and say node demo.js, I see a message that says test message with 2 commands and results, and it has this array that has 2 objects in it, one for each command. This one says completed true, and this one says completed true and rover status object, which may not seem very helpful, but that's because it's trying to stringify it and it can't do it. So because there's so many nested things, right? It gets to a point where it's not going to lay it all out for you, which means I'm going to need to be more specific with my console log. So I can come back here and say, okay, instead of the response, let's just give me response dot results and show me just that. And now I run it again. And now I see the results array. So this is the same array that is stored in this results key right here from here, but now we see it in more detail. And now this looks a lot more like it does in the screenshot right here, right? Where the first object says completed true and the second object has both completed and rover status keys. And the rover status value is this object with mode generator watts in position. And I'm getting exactly the same results here that they're getting here, which tells me my code is working properly. So you can use console logs as much as you need to. You can even do it like this with a separate file if you would like, or you can just do it from your tests. And when you run your tests with npm test, you'll see the console log show up at the top. So however you need to, but use that as often as you need to make sure that your references are right, because maybe, I wasn't sure what it was. And I could say, okay, I want to go to the results and I want to go to index 1 and I want to check the rover status. And, let's see what that was. And I'm not sure if this is the right way to get to the data I'm trying to look for. And then you run it. And yes, I got exactly the object I was looking for. This is the value of response.results at index1.rover status. So that's the kind of thing you want to play around with and make sure that everything is exactly what you think it is. Okay. Run all tests with npm test every single time you add a new test. And so, I mean, even if you're using something like Just Runner and you are running one test at a time, make sure you go back and run all the tests so that you are making sure that you did not change the code in a way that is now breaking one of the tests that was previously passing. Then that's just standard TDD. But I wanted to remind you. Make sure you clean up your code before you submit if you have code that you ended up not using, or unnecessary comments. Make sure those are removed. Make sure your indenting and line spacing and semicolons are all sorted out so that it's easy for you and for your IA to read. And for task 1, I would recommend that you just make sure you're clear on what that TDD process is before you get started, and remind yourself that you really do just want to do one test at a time, just like they remind you there, so that you don't get frustrated. For task 2, this is the command class. Make sure you understand how that test for throwing an error works. I explained it in the video. You can always come back and watch this video again and go back to that part if you need another refresher. And then make sure all 3 of those tests are passing before you move on to task 3 with the message class. For task 3, they're all going to be pretty similar. So that's my best advice there. And then just make sure that the tests 1 through 6 are all passing before you move on. For task 4, make sure that constructor is working properly for test 7 before you move on to test 8. Because you don't really want to bother with receive message until you're sure that you've got the constructor set right with all 3 of the properties for the rover. Then study that example really carefully to make sure you're understanding how you're supposed to build that object with your receive message method so that it returns the object that looks like this with as many results objects here as you have commands that are passed in. There we go. Study those tables carefully so that you understand how each command updates the rover and generates a different return object in that response. And then make sure all 13 of your tests are passing before you run the autograder test. And then, of course, for task 5, if test 14 fails, even if your other tests were all passing, you probably have false positives in your test, which means you need to actually make sure you were testing what you were supposed to be testing. And you might have to adjust your test, you might have to adjust your code, and you might have to adjust both. It's just going to depend on what the issue is. If you get to the point where you're trying to diagnose it and you just can't figure it out, that's definitely when it's time to go get guidance from one of your IAs, so you're not banging your head against the wall and you can get things across the finish line. So speaking of which, make sure you share your code only with your IAs. Graded assignments, you cannot talk to your classmates or anybody else that you know in the world around you who is a developer. You really need to show LaunchCode that you can do this by yourself. And if you get stuck, try to debug it. You learn in the process. Recheck the instructions, go back to the book, go back to lecture slides, do some online research, whatever you need to do to refresh yourself on the concepts. And then walk away if you get, a little bit frustrated, come back and try again. Sometimes just going away and clearing your head and giving yourself a break can make a huge difference. Make sure you're attending office hours or meeting up with your IAs to get one-on-one help when you get stuck. And then stay in regular communication with them so they know how you're doing, because this is a big assignment. You're going to be working on it over the course of several days. And just make sure they kind of know where you are, and if you are stuck and need some assistance to get that scheduled so that you can move on. All right, so if you would like to do a little bit of extra work to prepare for this assignment, I have a full tutorial on my website called Backpacks, which has multiple classes and lots of unit testing. And it's currently exists on Replit because that's where this assignment actually used to be. And it's based in Jasmine. So the syntax is slightly different. You're going to see it blocks instead of test blocks, for example, but it works the same way. So even though, since Jest is built on Jasmine, it's just going to be almost the same. So don't worry too much about slight syntax differences in that sense. The value of this particular tutorial is in the problem-solving aspect and being able to think through how to write the test, how to form up the object so that you're accessing the keys and values properly, and understanding how it all fits together with these nested objects and arrays of objects. Because that part is pretty new to you guys to be able to work with data structures that are a little more complex. This assignment can really help you think through all of that. So you can go to the website and take a look at that. And hopefully that will help you get an even stronger footing for knocking this great assignment out of the park. So that's all I've got for you. I wish you the best of luck on this assignment, and I'll see you next time.